Welcome to Morning Coffee with Trevor. My name is Trevor Matthews, your host, and today I'm starting Morning Coffees with Trevor. I'm super excited about this. I love coffee and I love talking about refrigeration, so I thought this would be a great thing to get started. A little bit about my background is I love refrigeration. I love talking about it. I love sharing my knowledge. I love training and education. I never knew that I really wanted to train or be an educator when I was in the field. And I really took a loving to training probably about 5 or 6 years ago when I started working for a manufacturer. And I started to really develop my skills at training, sharing my knowledge with others. And during those times, I learned a lot of different things and a lot of different skills about training and education. And when I started to develop different technicians and sharing my skills and sharing my knowledge, um, I was really getting a lot out of that, and I was really enjoying um, training and teaching people how to do their jobs better. And I really started to dive into understanding compressors and troubleshooting compressors, because when I started out in the industry, I thought I knew a lot about compressors. I thought I knew how to troubleshoot compressors really well. But over time and starting to work for manufacturers and learning about compressors, I'm like, wow, I don't know as much as I should know about compressors, especially in the field. Even though I was troubleshooting them and I was repairing them and fixing systems, there are so many times that I've seen and noticed that I did not troubleshoot it properly. I replaced compressors that probably didn't need to be replaced. And over the years, I started to learn about how to do this. And this is what it's I really like to do, is to learn how to do it properly and then share that knowledge. Hey, Erin, how's it going?
Good morning. I'm on a different computer, so this one's working better.
Wow. So where are you from, Erin?
Rosedale Tech in Pittsburgh, HVAC instructor here.
Awesome. Thanks for joining.
Yeah, thank you. Great to have coffee with you. This is a great honor. So I listen to you and Brian Orr's podcast, like almost listen to those all the time, and all your videos are great. So I've learned a lot from you. Thank you.
Awesome. Well, I'm glad you're joining me for a coffee. It's something new that I'm starting, trying to just give back and share some more knowledge with everyone. I meet more people, right? Networking, I think, in our industry is so important, and really getting that help and sharing that knowledge. You got a class today?
Yes, not for another hour, but yeah, big class today.
Okay, how's it been going?
Really good. School's great here. We have a great day and night HVAC program. We were only closed for 6 weeks for the plague, and ever since then we've been back in time, full time in person. It's going great.
Okay, awesome. So what's your role as at the school? You instructor? Do you have many roles?
HVAC instructor, and my students and I take care of all the heating and air conditioning, refrigeration in the buildings.
Awesome. So how's your program laid out? Do you do like a bit of theory, then you do a bit of hands-on? How do you do it, Erin?
In the mornings, we do theory and on the smart board, and it's very interactive and very engaging. And then we have lunch, and then every afternoon we're in lab. Even the very first day, the very beginner students are in lab the first day, learning electrical safety and wiring up plywood boards and do lab every day. It's a hands-on trade, so we're a hands-on school.
Oh, that's awesome. Yeah, and you got to do that, and really just show the beginners how to do it, and then work your way up to more advanced training. You know what I mean, over time. And I've been to multiple trade schools across Canada, and I love the way they do it here. Is a similar approach. I don't know if yours is a full like 1 year, 2 years, or like intermediate program, like block program. How does it work at your school?
We have our main programs, the 2-year degree, associate's degree in the daytime, and then we have an evening diploma program, and then we also teach operators, engineers classes here at night for HVAC and electrical, and we also teach air conditioning contractors Western Pennsylvania classes too, which is employer sponsored.
Awesome. That's great. And that's the way it kind of is here in Canada, employer sponsored. Well, it's apprenticeship. So you go to school for, 8 months. You go to work for 8 months, and then 2 months you'll go to school, and then the other 10 months, next 10 months, you'll go to work. And then, you do that for 4 or 5 years to work towards your journeyman certificate, which is really good. So I'm going to jump into some of the things I want to talk about today and kind of share with you. And if you have any questions on it, feel free to join in. But what I was talking about a little bit earlier is about how I really enjoyed training and sharing my knowledge with technicians and instructors and manufacturers. And I really was falling in love with training on compressors and the mechanical device and understanding what's going on in the system. And it took me many, many years to get where I'm at, especially on the compressor side, because there's so many different types of compressors, so many different types of manufacturers of compressors, and they all work a little bit differently. Like I used to think, okay, a scroll is a scroll or semi-hermetic is a semi-hermetic, but there's different uniqueness in all of them. Like Copeland has over 20 different scrolls, like different sizes, different internals, different applications. And it's no different with semi-hermetics. There's a lot of different styles of semi-hermetics, and then you have unloaders and digitals and variable speeds. And so when you start to learn about these different topics, it doesn't happen overnight. Because I used to think, oh, well, I'll learn this and it just happens. No, I've been spending 17, 18 years now in refrigeration, and I'm still learning every day. And now I train full time, and I learn even more while I'm training, which is fantastic. And some of the things that, hey, good morning, Joel. How you doing, brother? Some of the things that I've been really learning is understanding the mechanics and the science around how the compressors function. Because a lot of the times, and what I'm seeing more and more, even when I was working for the manufacturer, and even now, is that as technicians, we don't take enough time to figure out what caused the problem. And I've seen this more and more in having the conversations, because a lot of times as a technician, we're on a tight schedule. We need to get this job done and we need to get to the next job. And we put a lot of pressure on ourselves. And when we're not, when we get that other call to go to, and you get dispatch call, and you need to really take the time to figure out why that first one has an issue or failed. And if you get it up and running, you should really understand what you did to get it up and running. Because there was many, many times as a technician in the field, I got a piece of equipment up and running and I wasn't sure what I did. Like, how did I get that up and running? And, like I did this and I played around and I checked the wires and I played with the contactor, a relay, and then I turned the switch on and started up, and it didn't trip off for another hour or 2 hours or even 2 days, but I didn't know really what fixed it. But in refrigeration, it's all about facts. There's nothing that you should be assuming, because it's about pressures, temperatures, electrical. And I've seen this time and time again where compressors would come back when I worked at the manufacturers, and there's nothing wrong with them. There's nothing wrong with the compressors or the components. Could actually send them back out to the contractor. And this is something that I really want to help with sharing, because I know I was a technician in the field and didn't have the opportunity to learn that stuff. And even now, there's lots of technicians that I talk to and say that, Trevor, this is the first training I've ever been in. I've been in the industry for 10 or 15 years besides my apprenticeship. And so I'm just trying to figure out how to get this knowledge out there. If you guys have any questions, you can throw them in the chat or just unmute yourself. But I'm going to talk about some mechanical failures today that I seen time and time again, and that you wouldn't really see unless you dove into those compressors. Like you took the compressors apart, cut them open. For one example is like contamination. Contamination is a one that is creeping up more and more, and it's due to either improper practices, not installing the system good from day one or to the manufacturer spec. A big one is not using nitrogen, flowing nitrogen through, brazing up the system. When I started out in industry, I didn't even know you needed to do that. I did not know. They might have mentioned it in the school I was at, but in school, it goes by so quickly. When I got out to the field and I was working with lead technicians, mechanics, they didn't use they didn't braise with nitrogen flowing through it, especially working in the supermarket side, because that's mostly my background, working in supermarket. We weren't braising with nitrogen when I first started out until it was started to be spec'd into jobs. And until we had to do it, I never did it before. My role was to go in and then replace the filters afterwards or change the oil after a couple of weeks. But there's a lot of problems that lead to that, and that's where contamination comes in. As well as another one is not pulling a proper evacuation. I've seen this time and time again. You put the vac pump on, the technicians don't have a micron gauge properly to pull the evacuation down below 500 microns. So some manufacturers want it down to 250. You want to make sure it doesn't rise too high. Do a static rise test over a certain period of time, depending on the manufacturer. Like, you want to make sure there's no leak in the system, because one of the telltale signs of contamination in a system, especially with POE oil, which is very, very hydroscopic, which absorbs moisture. And when that happens, you can get something called copper plating due to acid. So when you get moisture in POE systems, it causes acid. And this is something you don't really see. You don't see if you're not looking inside the compressor. And I've been talking to hundreds and hundreds of technicians over the years, and they're like, I don't look in compressors anymore. If it's not running, I just change it, to be honest with you. I don't have time. It's a process that needs to be up and running. It's a multi-million-dollar process, but you do have the time. It doesn't take very long to pull a head off a semi-hermetic, for example. It doesn't take a lot of time to look inside to figure it out. Yes, it does take time, but you do need to know what you're doing, do it safely as well, right? You need to understand how to pump that compressor down properly, shut the electrical off, lock it out, tag it out, and then remove the certain bolts. And you don't want to remove them all the way on a semi-hermetic. You want to leave them in a little bit and knock the head off so you don't get splashed with oil and stuff. But it's very important that you take the time to look inside, because if you don't look inside, you're not going to know if there's contamination inside there. And contamination, especially with copper plating, doesn't happen overnight. Like, it could take 6 months, could take a year, it could take 2 years before you get enough acid to start and break down the windings or cause that compressor to fail. That's why it's so important to take oil samples. And I know for sure not enough technicians take oil samples, especially on larger systems like rack and parallel systems, because if you're not taking an oil sample, you don't know what that oil is. If you're taking over a new job site, and it's a large system, you should be taking oil samples. Now, if you got packaged rooftop units and there's hundreds of them, well, you're not going to be taking samples of all of those. But on bigger systems, big chillers, big racks, and you should be doing that. And we're seeing more and more of this in the CO2 application, where manufacturers are seeing them where there's two things happening: contamination happening, as well as floodback happening on CO2 compressors. Yeah, go ahead, Joel.
Hi, good morning, everyone. Morning, Trevor again.
How you doing?
I'm good. When you say oil samples, let's say you don't have a rack, but you have, like, let's say about 3 or 4 single condensing units. Is it advisable that you would say also to take oil samples from each condensing unit, well, the compressors, to see what's going on with your oil? That's one. And also, two, how do you take oil samples? It's a kind of tricky question. I don't think I never done it, but how do you take oil samples from, let's say, like the scroll compressors? I've done it with the recips, the semi-hermetics and stuff. So how do you actually take it, especially from the scroll compressors?
Okay, so for the first question, if you can't, if it's a smaller system, if you have a sight glass, the best thing is if you can look inside the compressor, if the oil is dark, if it's colored, or if you're opening the system and the oil smells, you want to take an oil sample. Because on the smaller systems, unless you've done the installation, you don't know if it was done properly, right? So if you're not taking an oil sample, I would look at the sight glass and to see if it's dirty, if it's discolored, and that's usually a sign of oil issues. You know, and it could be acid, but it could be done from heat as well. But heat can also cause acid in the system because it starts to break down that oil, right? Depending on how hot it got. Now for the screw compressors, I have not taken oil samples from there, but I'm actually doing a training on Thursday about it. And that's a question I'll ask. So I'll get back to you with that, Joel, on how to properly take oil samples from there. Have you taken an oil sample before and done a tested oil before?
No, I never took oil samples from a screw.
Okay.
Yeah.
But you have for a recip and tested it to see if there was any acid in it and stuff like that?
Yeah.
Okay.
Yeah. There's a normal acid test kit, but I know they also do things. Poland has like an oil analysis kit also too that they said that you can use that actually gives you a breakdown as to what is going on with the oil, impurities, copper shavings, all these things. I think that oil analysis kit does, but I never done it. But I heard about it. I heard it actually gives a real detailed breakdown.
Yeah, and it's important to do that, like, because a lot of technicians don't. I was doing a training yesterday, and they asked, like, well, when should I do an oil sample, or when? You know, I took over a new store, and like, I don't know when the last time the oil was changed, because oil has to be changed in a rack if the oil's bad or if it's starting to get bad, and it's expensive to do. But what a lot of time it happens is that it's very reactive. What happens is where you have a major failure, and then the customer is like, okay, well, do it now, you know, because oil is expensive. Like I found out yesterday on the new Carlisle, or not on Carlisle's, the oil, you only can use Carlisle oil, and it's like $200 a gallon. Like that is expensive. And then other manufacturers have specific oil they want. So the POE oil is very, very expensive. So it's something that you want to plan with your customers, but you need to check, because a failed compressor on a large system, and that system's down, we'll say, that's going to cost the customer a lot more money than if you do a planned oil replacement, oil change, because that should be done in your yearly maintenance anyway, checking the oil, changing the suction filter, changing the liquid filter, oil filter, depending on how your company lays out that PM. And I highly recommend doing that checking. If the oil sight glasses on the compressors, OMBs or oil pots are really dark and dirty, you should be checking that oil to see if it is, and doing an oil change out. Oh, that's good. I got this this cup from a company called LabWorks International. It was the last training I did for Emerson when I worked for them, and it's a Yeti. I don't know if you guys have these cups, but man, it keeps your drink really hot for a long period of time. I know, Joel, you're down in the Caribbean, so you're drinking some cool drinks down there. Maybe it's real hot.
Yeah. Funny enough that you said that, I can't remember the name. I have to ask my girlfriend. She actually ordered some cups like that from Amazon. I can't remember the name, but I will actually, when I get the name, I'll private message you. And those cups are the bomb. I made tea at about, let's say, a day like about 7 o'clock, and let's say it was around 9. I nearly burned off my tongue. I was like, this still, wow.
I know that is exactly like this mug here. I gave it to my wife, and like 2 hours later in the vehicle, driving somewhere, to open it up, and it's still burning hot, which is really cool. Because it's nice to have a warm drink, especially because I got kids, and then you get caught up with stuff, and then I get phone calls from people, and then all of a sudden you get into your coffee or your tea, and it's still a good temperature. Rick, great question. So when changing from mineral oil to POE oil, is there a maximum % of residual mineral oil to be allowed for sure. Both Copeland and Bitzer both have guides that'll talk about it, but in the Copeland one, it's called the 9311 guide, and it's going to talk about when you're retrofitting from say R22 mineral oil to say 407C, 448, 449, and they'd like to see 95.5 percentage. So you're going to have to check that percentage with like a refractometer to make sure that you have as much mineral oil out of that system. So I'm not sure what types of systems you work on, if you work on package or racks, but you need to definitely on a rack application, when you're doing a retrofit, it's all about planning that oil change, because you might have to do it multiple times. You might have to change oil a couple of times, and you have to be aware of that. And you do have to check the oil to see what percentage of it, because just say you get 80% is POA and the other 20% is mineral oil, it doesn't carry the refrigerant the same way. So you're going to a 400 series like 448, 449, you are not carrying that oil the way it should be carried. And what's going to lead to is oil issues. And they've seen this huge with, I believe it was MO99 at one point, when there wasn't all the oil change. To be honest, most of the time, all that oil should be in the compressor. There's only a small percentage, through the system, like through all the piping and through the evaporator and condensers. Most of that oil should be in the compressor itself, unless there's too much oil in the system. But when you pull out the compressors and you change the filters and you blow out the lines, depending if it's a smaller system. Now, if it's a larger system, you'll probably do 1 or 2 oil changes. And what the way they do it in a larger systems, they'll plan it where they will start changing they'll do an oil change first. So if it's R22, you can run R22 in POE oil. So you'll run it with put POE oil and run it. And then what happens, the POE starts to peel away, clean all the copper. So you'll start to get plugged up TX valves, you'll get plugged up valves, plugged up filters. But what that starts to do is starts to clean the system. And so when you go to do the gas change, you're doing the gas change, you're going to do the gas, the filters, all the solenoid valves, because now you have all the TX valves clean and stuff like that, all the screens, because you're going to want to change gaskets, right? Because what's happened is that the gaskets that's been there for 15 or 20 years, say with R22, is going to change the structure of those polymers, and you can have leaks. And this is what I've seen so many times. If you don't plan and prepare, is that you can potentially have big leaks. I know it's a little more than what you're asking there, Rick, but it's important to get all those gaskets and find them, mark them all out when you're doing a larger gas retrofit. But yeah, 95.5 is the percentage you're looking for, POE to mineral oil in the system. That's good. That's good. I love my coffees in the morning. It definitely gets my day started. So getting back to contamination, that would be considered a contamination as well, Rick, if you don't change, get all that mineral oil out. The big thing is seeing copper plating on the compressor. Like scrolls, or hermetic compressors, a lot of people do not cut scrolls open or cut hermetic compressors open. But if you want to learn and understand what caused that compressor to fail, you got to do that. Yeah, and you're going to do it on every job? No, you're not going to do it on every job. But what you need to do is cut it open, take a look inside, and then if you see copper, you usually see it on the hottest points, so when you look at, say, a valve plate, you're going to see a lot on the discharge side. And if it's real bad, you'll see it on the suction side, and you can see it even on the crankshaft, on the valves themselves. And when you start to see that, really what happens is that acid in the oil starts to peel away the copper and bring it back to the compressor. And then if you see that, for sure you need to clean up the system. So you need to liquid line filter dryer. If there's a lot of acid, you need a suction line filter dryer, which needs to be replaced You need to replace that after, Sporlin will say, I think it's after 48 or 72 hours, you need to pull that out. And if you get a pressure drop across it, that means that it's starting to plug up some more. So it's important to replace those. And I've seen it so many times. And I even did it in the field. I've left suction filter dryers because I didn't know. I didn't know that I needed to replace it. I knew that I was pulling out the acid and cleaning the system, but I didn't know I had to replace that filter dryer. But it's important, especially if you start to get a pressure drop across it. Some manufacturers say if you're going to leave it into a permanent installation, there is a specific pressure drop you want to keep it, but this is something that needs to be checked. Yeah, go ahead, Joel.
All right, as you said that, Trevor, not to let me pose a question. Those suction filters on the rack. Let's say you would have removed them. And let's say that rack is at an existing location, but they're gonna take that rack now and put it to another location, putting in mind that they would have done load calculations, it could use at another location. And you have to do an install now, a reinstall using back that rack. Do you now have to go back now, get suction filters, put them back in, get new suction filters, put them back in for that install. And when you start up, then you pull them back out again?
Yeah, so I would always, so some people, everyone has their own opinion on this. Some people like to leave suction filters in. Some people don't leave suction filters in, they pull them out. For me, if the system was not properly installed, not brazed properly, there could be copper filings, you should be leaving pleated filters in. Pressure drop in the suction is the worst that you can have. Is really bad for compressors because that compression ratio, and we'll talk about that over other coffees, but I would put at least minimum pleated filters in, because when that new install happens, you're cutting more pipe, you're reaming more pipe, you're sanding more pipe, and that's potential to get back to the compressor. So I would put the filters in, at least the pleated ones, to protect any shavings or copper getting back to that compressor to short it out. Hopefully that answered your question. Rick, go ahead.
Actually, that was the exact same question I was just going to ask. Yeah, it was just because I've always read from different manufacturers like Hussmann, and a lot of their literature will say to remove the suction filters after a certain amount of runtime. And I hear everybody's the same thing. Like, I've heard opinions everywhere. I'm big on leaving them in, especially as long as you're servicing the store, you can check the pressure drops and stuff.
Yeah.
I don't see how it can hurt, as long as you're making sure that, like you said, there's no pressure drop. Because it's pretty easy for somebody to come along and do a quick little install somewhere and not even check if there is suction filters in there, and do a lot more damage. So
yeah, no, and that's exactly it. So everyone, you can do it either way. Pressure drop's a big thing. That's why you got to check that. You don't want that pressure drop. You drop that suction, you lose efficiency in the thing. But it's better to have, say, a 1 psi pressure drop than losing a compressor or two compressors, like a 6D or, a large compressor, because you're talking tens of thousands of dollars potentially on the install, and maybe customer downtime. So it's up to you. You make the decision if you want to leave it in or not, but you got to understand how clean is that system. Should I leave it in or should I not? So depending on manufacturers, depends on that. So thanks. Go ahead, Erin.
We changed a 6-cylinder Carlisle compressor here in one of the air conditioners in the school. And we broke a rod, but it was old, and I just assumed it was wore out. So the local carrier place said, I'll sell you a new compressor. And, the students did it and everything. It went fine, but let's take the old one apart and look at it. So we found some play in all the pistons, and we broke that one rod. So we figured out we were getting some liquid back. We had some low load issues, and we fixed our unloaders to fix that. But we also found some copper plating in there, which, so, all right, now let's look at acid. So we changed the oil a few times, changed the suction dryers, and we left the suction dryers in there, but we kept an eye on the pressure drop. So had that engineer not suggested, hey, let's look into this a little deeper, you may not just have wore out an old compressor. We would have never looked at any of those other issues.
Yeah, and I've heard that so many times. Oh, well, it's a worn out compressor, I need to replace it. Well, It's not really a worn out compressor. It's a damaged compressor, because compressors, it doesn't matter if it's Copeland or Bitzer or even Carlisle's, they'll last 10, 15 years. And if it's after 2 years or 3 years, the compressor is loose or got worn bearings or smashed rods, it's due to system related issues. Rick, go ahead.
Oh, sorry. I must have accidentally put my hand up again.
Awesome. Okay. I want to thank you very much, all of you, for joining on coffee with me this morning. I'm going to do it again tomorrow morning. So if you want to grab some questions, grab a coffee, and I'll see you tomorrow morning.
Thanks, Trevor.
Thank you, Trevor.
Okay.
Everyone enjoy the day.
Have a good day, guys.